Hello friends, this is Durga again from Technology Mentor / ITversity, and as part of MapReduce application development, we have seen so many things so far, and at this time I would like to explain you more about compression. When it comes to compression, uh, these are the most important things you need to understand. First, compression types, which are categorized into splittable versus non-splittable. Most of the compression algorithms are non-splittable, and compression codecs, and then compression configuration. Compression codecs will tell you which compression should be used at the time of executing the MapReduce program, and compression configuration is to tell whether the final output which will be returned to HDFS needs to be compressed, or even the intermediary files which are generated while we run the MapReduce programs also needs to be configured. So there are several parameters which you need to understand uh, related to compression configuration. So first, let us get into the details about splittable versus non-splittable compression. For this, I am directly going with an example. So we have a 20 GB file, and let's assume that our block size is 128 MB. So with 128 MB, a 20 GB file will be divided into 8 into 20, 160 blocks. And let's say our HDFS is of size, our Hadoop cluster is of size 10, and replication factor is 1. So there are no duplication of blocks as far as fault tolerance. For simplicity's sake, I am just taking the replication factor as 1. So 160 blocks will be distributed across the cluster. On average, each node will get 16 blocks because we have a cluster of size 10. If it is splittable compression, let's say we have 20 GB file, and we are using splittable compression. Approximately the file can compress to 2 GB. It varies depending upon the algorithm you are using, the nature of data you have. So there will be so many variables which will determine the compressed file size. But for simplicity's sake, I am taking it as it is compressed to 2 GB. When it is compressed to 2 GB, as our block size is 128 MB, instead of having 160 blocks, now we will have only 16 blocks, and those 16 blocks will be distributed across all the 10 nodes in the cluster, which means each node will get approximately 1.6 blocks, which means approximately 2 or 1 on each of the node in our cluster. Typically, splittable compression will compress at lower rate because it has to identify the physical file boundaries, which are blocks in this case, and for that reason it will be lower compared to non-splittable compression. And also, splittable compression does not use native libraries in most of the cases. For that reason, even there will be some performance overhead with respect to splittable compression compared to non-splittable compression. And now, non-splittable compression, for simplicity's sake, let's take the example that the compressed file will be of size 2 GB. Typically, when you compare splittable and non-splittable compression file size will be smaller than the splittable compression. It will not be significantly smaller, but still it will be smaller. But for simplicity's sake, let's say it is of size 2 GB as well. And now, instead of having 16 blocks, even this one will have 16 blocks, and those 16 blocks will be distributed across the cluster. So the point is, whether you use splittable compression or non-splittable compression, the only difference is the size in the compressed file when it comes to storing into HDFS. But the way it will be divided into blocks and distribution into the cluster will be the same. Whereas when it comes to MapReduce, so earlier we have spoken about HDFS. Now we are talking about MapReduce. So this is the HDFS picture which copied from the previous slide, and this is how it will be. Our 20 GB file will have 160 blocks because of our blocks is 128 MB. If you store in an uncompressed format, each node in our cluster will get 16 blocks at a time. Whereas whether it is splittable or non-splittable compression, the size may vary, but it will be approximately 2 GB with certain assumptions. And if it is 2 GB, whether it is splittable or non-splittable, as the block size is 128 MB, there will be 16 blocks for this compressed file, and those 16 blocks will be distributed across all our 10 nodes in the cluster. Now the actual difference comes. Now let's say you want to process the data, and for processing the data, take the split size same as block size, and if you want to process uncompressed file, you will see 160 mappers to process the data, and those 160 mappers, depending upon the capacity, will run at the given same time, or it might slowly finish the job. Some mappers might be in pending, some mappers might be in running stage. It all depends upon the cluster capacity. If you use splittable compression, the behavior will be same as the uncompressed file. Only thing is, you will have fewer mappers instead of 160 as with the uncompressed file, and those 16 mappers will be executed on wherever wherever the MapReduce framework feels it as feasible. And then when it comes to non-splittable compression, instead of 16 mappers, there will be only one mapper. That's why it is called as non-splittable. Okay, so what will happen? Let's say you have two files. Sorry, you have approximately 2 blocks on each of your 10 node cluster. That means to process this 2 GB data, wherever it kicks in, there will be only 2 blocks available on that, and rest of the 18 blocks most likely will be on the other nodes in the cluster. So our MapReduce job, if it is using non-splittable format, it has to copy data from all the other nodes to the node wherever this map is running. So it will end up a tremendous amount of network I/O, and also it will be serialized process. There will be no more distributed computing capability. So this is the major difference between splittable and non-splittable compression. The way data stored in HDFS will be same whether you use splittable or non-splittable compression, and it will be same as uncompressed file. Whereas when it comes to MapReduce, a non-splittable compression, if the file size is too big, then you will compromise data locality. So that being said, should we use only splittable compression all the time? If that is the case, why we have non-splittable compression also? To answer that question, most of the algorithms are non-splittable compression, and when it comes to non-splittable compression, they can be far more better in performance compared to splittable in both the compression rate and also the processing rate. Then why should but as we have spoken earlier, the shortcome of it is that if the file size is approximately 2 GB, instead of having 16 mappers, we will have only one mapper to process the data. So how to overcome this? One way is to make sure that your file size is not too big compared to the block size. And in that way, so if you remember, the way mappers will be determined is solely depend upon the file size, and if unless you use combined file input format, if you have a file of 1 MB for a 1 GB data set, if you have 1000 files, there will be 1000 mappers that will be invoked if you are not using combined file input format. So using that approach, you have to make sure that the compressed file size or the non-splittable compressed file size is close to block size, and you have a few files instead of having one file for this 2 GB data set, and then you will get the advantage of both. You will have a better compression rate, and also now mappers can be invoked on different nodes in the cluster, leveraging the true distributed computing capability. And that's how you should actually think about solving your problem. In some cases, it is inevitable to use splittable compression. In some cases, it's better to use non-splittable compression if you can control the size of the files. That being said, these are the compression types which are supported as of now: gzip, bzip2, lzo or lz4, and snappy. And if you look at this table, the actual algorithm which will be used for default one as well as the gzip is deflate. For bzip2 it's bzip2 algorithm, lzo it's lzo algorithm, lz4 it's lz4 algorithm, and for snappy it's snappy algorithm. And the file name extension will be like this. If you are using deflate codec, it uses deflate extension. If it is gzip, it will be gz extension. If bzip2, it is bz2 extension, and lzo for lzo, lz4 for lz4, and snappy for snappy. And then splittable, if you see, most of them are non-splittable except bzip2. And however, LZO files are splittable if they have been indexed in a pre-processing step. So this is one thing you need to keep in mind. You have to index your LZO files to make them splittable. And then these are the codecs which you need to define as part of your course.xml. So let me go to our cluster and show you what I'm talking about. So I'm going to cd etc Hadoop conf, and if you go to course.xml, so if you want to use compression, first you have to add all the codecs which you want to use in course.xml file. In this case, it is capable to use gzip codec and default codec and snappy codec. Only these three are enabled now, and if you want to add more, then you can add others also to that file. I'm sorry. And then the below table will tell you whether the compression format is a Java implementation or native implementation. And wherever there are native implementations, it's highly recommended to use native implementation because the performance is much better. Except bzip2, everything else is everything else have native implementation. So if you are using plain vanilla Hadoop, when you set up the Hadoop by downloading the binaries directly from Apache, it will complain saying that the native libraries are not available, and hence I am using Java libraries. If you want to overcome that, you have to compile your code to generate. You have to download the source code of the Hadoop. You have to compile it and generate the native implementations. And unless you use native implementation, you cannot use algorithms like Snappy. It is very important to understand this one. Okay, and if you want to learn how to do that, if you are using plain vanilla Hadoop by any chance, I have a playlist on my channel, and it is called as plain vanilla Hadoop. And here I have explained how to compile native libraries from Hadoop source code using Maven. And for other clusters like Hortonworks or Cloudera, that is all taken care by the respective distribution. So you need not worry if you are using Cloudera, Hortonworks clusters or virtual machines. But if you want to use Snappy, which is one of the highly used algorithm in Hadoop, you have to have native implementation. Without that, you will not be able to run a snappy algorithm. And if you want to compress, if you want to use compression, so there are several files which you need to go through and understand the parameters and make changes to those respective parameters. So one is course.xml, which I have shown earlier. So IO compression codecs is the parameter in course.xml, and you have to tell what all compression algorithms you want to use. That doesn't mean that you can only use these things unless the parameter is defined as final. So even though they are not defined here, you can still use by setting certain parameters at runtime as part of your programs. Okay, and then for MapReduce programs, if you want to use compression, then if you want to make it permanent, then you have to go to mapreduce.xml and you have to set this to true. Unless you set this to true, the compression will not be used. And there are several parameters which you need to understand. And as the name suggests, this MapReduce map output compress will actually compress the intermediate files if this is set true. It will not compress the files that are going into HDFS as part of the reducer output. This will only let the output from the mapper to be compressed. This parameter, you have to set this true if you want to compress the map output. Otherwise, it will not be compressed. And then this will tell you what type of output format, what type of compression you want to use for the output files, which will get into HDFS. And here, if you want to use snappy, you have to provide the codec like this: org.apache.hadoop.io.compress.snappy. You can go here and see the parameter here. It's snappy codec, and you have to use that as part of this parameter if you want to only use snappy. But if you set the output compress to true, and the first parameter is 1 minute. I'm sorry. Okay, sorry. So the parameter MapReduce output file output format compress. If you set it to true, then only the reducer output will get compressed before copy to HDFS. So if you want to compress the files that are generated after running a MapReduce program, you have to set this parameter to true. Otherwise, it will not work. And here it will tell you how the data should be compressed, whether it should be compressed at block size or record size. Those two are the valid values here, and this has no meaning unless you have your map output or output compression is modified to true. Only when the file output format.compress is set to true, this will be in effect. Otherwise, it will not be in effect. And then you can add the codec here, or you can actually set as part of your program. It's not mandatory that you need to add codec here. If you set it here, and if you set the parameter to true, then all the files that are going into the HDFS will be compressed with that algorithm. You have to be very careful whether to set it to true at cluster level or not. Some cases you will be able, in some companies, they set map output to be compressed always. But when it comes to reduce, you have to do some due diligence to determine whether the files that are generated after complete MapReduce execution have to be compressed or not. That being said, that's it about compression theory, and in the next video I will try to cover how we can actually set the compression codecs to read the data, write the data, and how I will try to explain you how all it will work for our same program which we have developed earlier, which is the top 3 stocks per year, and top 3 stocks per day by volume. And then you will understand at MapReduce level how this compression can be set so that we can compress the data to cut down the costs of storage. That being said, I hope you are enjoying the content so far on my channel. If you have not subscribed yet, please do so. If you like the video, please click on the like button, and if you want to provide a feedback or ask me a technical question, please leave it in the comment section of the video. Thank you. Bye.